A thrift store find. That'll be torn apart. I paid a massive 75 cents for this. I got ripped off. Oh well. It's missing 400 pieces. There's little things that plug into each of these holes, which are different color, so that you can make faces, different patterns, etc. You can look it up on the internet. It's called GlowBots, but there's a whole bunch of different GlowBots out there, different manufacturers. This one was Pressman Toy Corporation. So what you do is you hook up your USB micro. I'll just go through the colors first. First button on this side, red, green, pink, blue, a couple of pinkish whatevers, ditto again with some yellow in there, I think, green, red again, etc., etc. Now, if you push and you can actually see there's, if I move it slowly, there's 2, 4, 6, 8, 10 LEDs in here. So if I push the middle button, and there's no battery in this, it then just cycles through them. It's basically a glorified night light that you can, if you had the complete set, make up faces, patterns, etc. Now the third button on this side, which is actually labeled number 1, does that standard fading away. So now what I'm going to do is take it apart. And it has 2, 4, 6, 7 screws. I'd like to use this one to take it apart, but this just does not reach down those deep holes. So, a good old handy one of these. I've had this one around for basically ever. Now I can get at those ones. If you hear any loud noises in the background, it's probably the window or the trees bouncing around. We've got a bit of a winter storm coming in, which they glorify every year when we get it, but it's called winter. And on the west coast of Canada, that usually means lots of rain. And occasionally, if you're at the lower altitudes, that rain might turn into snow. If you're at higher altitudes, you can bet it's going to turn into snow. The one ski hill I believe we have on Vancouver Island would be very unhappy if it didn't turn into snow. Okay, hey, that came apart easy. Okay, I'm going to adjust the camera. So we got 10 LEDs here. They're probably addressable. I suspect all the circuitry is on the one side. We've got our standard flux laying all over the place. It's not too bad. That would have been on the last solder. All of this would have been machine. And then probably the Yaman did this part. And these ones in here. What I'm going to do is take off these last screws and see if there's anything on the other side of the board. Got those 4 screws out. Should just be, yep, push buttons. And the USB connector. And that's it. Made in 2019, the 4th month, 28th day, version 1.3. And it looks like, since I got a B plus up here, I wonder if they originally thought about throwing a battery in this, because they've got a marking for another capacitor here, which they're not using. So what I'm going to do now is create a schematic for this. The circuit's actually fairly simple. Here's my first drawing of the schematic, and then I realized that I could really simplify it. So essentially we have the little microcontroller. That's right here. There's no number on it, of course. And it comes across over to the switches. This switch here, I'm not exactly sure what it's doing. It is pulled up to the positive through a 10K resistor. So when you push down, it's basically going to bring this pin low. I didn't notice much change in the function on that thing. The other two control if it's just a steady on and you can click through the colors, or if you want it going dim and then to the next, and etc. and etc. So the power is going in here, pin 1, through diode 1, which is an M7. And then there's a couple coupling capacitors there. Don't know what the value is. I'm not going to pull them out because I don't want to destroy this thing. I will be putting it back together and tossing it into another thrift store. So the outputs, you've got 3 of them for the LEDs. Originally I thought they might be addressable. No, they're just straight RGB ones. So this here, each of these transistors has a 470 ohm resistor going up to the microcontroller. Poor graphics there, coming across. So each of these is going to cover the red, the green, the blue, and this thing here is going to determine what level they're at. So it's almost all in parallel. So LED 1, 2, 3, 4, 6, 7, 8, 9, and 10 are all wired the same. I'll put in the corner close up of it, and essentially they go in on this side. On the other side, there's 47 ohm resistors. The markings, of course, is 470, indicating there's no multiplication here. So 47. There's a lot of 47 ohm resistors on this thing. And then that goes up to the positive. So that's actually almost all of them. There's one outlier, though. LED number 5, which is over here. Instead of putting the resistors on this side going up to the positive, they put them on the other side for some reason. But other than that, there's still 47 ohm resistors each, and that's a bit different. Had me confused for a little bit. The other area that I had a tiny bit of problem was this resistor here. When you look at it on this board, you're kind of like, oh, it's doing something. Okay, it comes up here. It just goes to a test point. Then it comes down here, goes to all of these. Of course, these in here are connected up to there. And I had to actually use the meter to find that it was connected. I couldn't see it. I'll clean up this flux before I reassemble it. But that's about it. Without housing on it, it is actually fairly bright. Kind of cute. And then the dimming one, well, dimming and flashing. And now I'll push this other button. Maybe the speed changed, I'm not sure. Interesting thing is that inside the programming in here, to turn it off, you actually then push and hold the middle button. So that's it for this thing. It's kind of cute. Not a lot of parts. At least their parts list basically 2 types of resistors, 10 LEDs, a couple capacitors, and the microcontroller. So that's it for this one. As I said, I'll clean it up, put it back in its package, and toss it off at the thrift store. Have a good one. Bye.